In this example, I'm going to go through how to do a vector diagram to figure out displacement. So here's the example. Chris Martin, who happens to be the lead singer of Coldplay, my favorite band, moves around the stage while performing. He moves east 15 meters, north 20, then west 5 meters. And the question's asking, what is his displacement? So what you're going to do is you're going to pick a point that makes sense. So I'm going to start in the bottom left corner because I know he goes east, north, and west. So according to your graph paper, that makes the most sense to start in the bottom left corner. And maybe I'll even make sure I'll move it down even more down here. And I'm going to write down my scale that 1 square is 1 meter. So by taking a ruler, you're going to draw out 15 meters. So 1, 2, 3, 4, 5, 10, 15. That's, so double check, 5, 10, 15. And then 20 up this way, 20 squares. 5, 10, 15, 20. Okay, so there's that second vector. And then he moves again west 5 meters. So 5 squares, 1, 2, 3, 4, 5, like so. So if you were figuring out distance, you would just add up 15 plus 20, 35, plus another 5, 40 meters would be his distance. But the question's asking for displacement, and we know displacement is a vector quantity. So we want to know, what is this resultant from the beginning to the end? So there's our resultant. So whenever you find your resultant, you want to make a right angle triangle from there. So if this is the ending point, here's the beginning, I can see the right angle triangle forms right there. And here is my right angle, where one side of the triangle is this length. Now, how do we find that length? I'm going to take a look, and this whole vector is 15, but I only want this length. So I count out, okay, that's 10 squares. Or I could also go 15 minus 5 is 10. So that's that length. Now this vector happens to be 20. It's the exact same length as that one. So we know the sides of the triangle except for the resultant. And in order to solve for the resultant, you can use Pythagoras' theorem. A squared plus b squared equals c squared. And rearrange that to solve where resultant is actually c. So if we want to solve for c by itself, if we take the square root of a squared plus b squared. Okay, so looking at a, that is 10 squared. B is 20 squared. And we take the whole square root of that. So square root of 100 plus 400. Square root of 500. And I don't know that one off by heart. So 500, and I'm just going to go second function square. So now we know that the length of the resultant is 22.4 meters. Because I have 3 sig figs in all of the vectors, so I'm going to put my answer with 3 sig figs, 22.4 meters. Thing is, displacement is a vector quantity, so we're not quite done. We know the length, but we need to know the direction in which it goes in. So what I'm going to do next is I'm going to establish where theta is. Theta is going to be inside the triangle, and always look to where he started the movement. So go back to that very first point, that's where we started, and you're going to put theta next to it. And Now we know where theta is. I know that 20 is the opposite side of the triangle and 15 is adjacent. So I'm going to use tan theta is opposite over adjacent. And opposite is 20 meters. That's the length of that side of the triangle. Adjacent is 15. Oh, sorry. No, not 15. I was looking here. Adjacent is 10. Sorry about that. So 20 divided by 10 is 2. The reason I didn't use 15 is because that's the length of this vector. I just quickly looked at it and I saw 15. 15 is this length. I just want this triangle right here, the made up triangle. That's what we're using right there. So the length is 10. So opposite is 20. The length of this side of the triangle is 10. 20 divided by 10 is 2. So to solve for theta, have that value in there. So 2. And how I do this on my calculator, in order to find theta, I'm going to go second function tan. And that gets rid of tan. It flips it over to the other side of the equation. And it also gives me the calculation. So once again, you have your 2 value, hit second function tan, or in this case, in my calculator, it's shift, and the angle is 63.4 degrees. So now you have your length, the resultant, and you have the angle. You need to write out the final displacement. So displacement is 22.4 meters. So let's say that's 22.4 meters east. And now we want to say, okay, if you're heading out east, it's about right here. It's about right here. But now we have to swing it up 63.4 degrees upwards. And upwards, in this case, in our cardinal points, that is north. So that's how you write that. You could, or another way of writing it is 22.4 meters, 63.4 degrees north of east. You can also say that as well. Either way. Okay, thanks for listening. Hope that helps.